Welcome everyone. This is our first lecture of software engineering, in which we will start with our sixth unit, which is software testing. We will move ahead. First point, which is software testing. So basically these are two different terms. Software is a set of instructions that tells a computer what to do and how to perform a task. And testing is used to check whether the system is working properly or not, or to check whether it meets the user requirement. So basically software testing is a process of checking if a software application work correctly and meet the user requirement. It also helps to find the error or bugs from a software before it is released. There are two types of testing. First is manual testing and second is automated testing. So manual testing is done by the human without any automated tools, and the automated testing is done with the help of automated tools like Selenium and WebDrivers. There are four testing levels. First is unit testing, second is integration testing, third is system testing, and fourth is user acceptance testing. Unit testing, it is used to test the small parts of the system. The integration testing, it is used to check if the different parts of the program or software are working together or not. System testing, it is used to check the entire software. And user acceptance testing, it is used to ensure if the user meets the needs. So next we will move to the next point, which is asked frequently in PYQ questions for the exam for 6 marks, which is software testing strategies. So we will first break down the diagram. The diagram shows the different stages of software testing in layers, from writing code to testing the entire system. First, code. The actual program is written. It is a format of a program. Second, unit testing. It is small parts of the program are tested individually. Integration testing. It checks if different parts of a program are working together or not. Different modules are working together or not. Validation testing. It ensures the software meet the user requirements or not. System testing. Tests the whole software to check its overall performance. Design. The structure and features of the software are planned. Requirement. What the software should do is decided. System engineering. The complete process of making the software is managed. This step-by-step process makes sure the software works correctly and meets the user needs. It is also an approach to test software application to ensure they meet quality standards, function requirement, and performance and expectations. It defines the overall testing approach, techniques, resources, and time to achieve reliable and efficient testing. So in software testing strategies, first is unit testing. Unit testing mainly focus on testing the small components and modules of the software application. The unit testing has limited scope. Multiple modules and components can be tested parallelly as well as individually. Unit testing is a software testing methods where individual components and modules of a software application are tested. It is typically automated and performed with the help of developer in development phase. It helps to detect bugs in early development cycle. It ensures logic is correct before integrating, improve code quality and maintainability. Why it is necessary or important? It helps to catch the error in early development phase, makes debugging easier, ensures small parts of the program work correctly before combining them. It helps to save the time in a long run. It is also an essential step in software development lifecycle, which ensure each function or module behave as expected. Some of its major characteristics are: first, isolated testing; second, automated testing; third, fast and frequent; fourth, white box testing. Let's move to our further topic, which is unit test process. We will learn this topic with the help of an example of calculator application, in which we have to test an addition function work properly or not. First, you decide what to test. For example, checking if the function add two numbers correctly. Next, you write the test by giving two numbers like 2 and 3 and expecting the result to be 5. Then you run the test by using the function and checking what it returns. Finally, you check the result. If it gives 5, the test passes. If not, there is a mistake in the code that needs to be fixed. This helps finding and fixing the error earlier, making sure every part of the software works well before putting everything in order. We will begin with our next point, which is integration testing. So integration testing, it is a software testing technique that verifies the integration between different components, modules or services of an application to ensure that they work together correctly. We will understand it with the help of an example. Imagine you have been building a toy car. You have wheels, the motor, the steering and the battery. Each of these parts works perfectly on its own, right? But what happens when you put them together? Does the motor drive the wheel? Does the steering works with the wheel? Uh, Integration testing is like checking if all these parts of your toy car work together as they should when combined. Why it is important? In real life software development, there are different parts or modules that make up complete system, just like the toy car. This could be things like login system, or payment gateway, or search engine. Each of these parts works fine on its own, but we need to make sure that they work properly when integrated. That's where integration testing comes in. It helps us to test different parts of a software, communicate and work well together. The integration testing has two types. First is top down and second is bottom up. So first, the top down approach. Uh, the higher level modules are tested first in top down approach, then the lower modules are added to it. Stubs are used for the missing components. The stubs are the dummy function or the model that stand for real module that hasn't been implemented or which are hard to integrate in early phases of testing. We will understand the top-down approach with a simple example. Imagine you are building a skyscraper building, a large building. First, you lay the foundation, then the floor, and then finally the rooftop. In the top-down approach, we start testing from the top, the higher level modules. First, we test the rooftop, then the floors, then the base, the foundation, and work our way down to the lower level modules. Another example, suppose user interface layer. You start by testing the user interface like someone has logged in or views their balance. Middle level. Next, you check if the user interface can talk to the backend services like verifying username or checking the account details. And at the last, the bottom, the database level. Finally, you check the database and ensure it stores the account information correctly. In this approach of top-down, you test the big stuff first and gradually brings it into a smaller parts. It's like starting with the top floors of a building and checking if everything works before moving down. And this better with the help of a diagram. In front of you, we have a diagram of top-down approach, which consists of top module, submodule 1, submodule 2, and the submodule 1.1, 1.2, 2.1, and 2.2. Suppose the top module are the rooftop, the submodule 1 and 2 are the middle floors, and the submodule 1.1 are the garden, the security cabin, parking lot, etc. In top-down approach, first we will check the top module, which is the rooftop. Then we will come in between, which is the middle floors. And at the last, we will check the garden area, the security cabin, or the parking area. Now let's start with our second point, which is the bottom-up approach. In the bottom-up approach, the lower level modules are tested first. Then they are combined with the higher level of module. Drivers simulates the higher level module. Drivers are similar to stubs. They are the dummy modules. We will take the same example of the skyscraper building, but this time you start with the foundation and then work your way up. In the bottom-up approach, you begin with testing the lower level modules, then you move way up to the higher level parts. For example, we have a diagram over here with different modules: module 1, module 2, module 3, 4, 5 and 6. In the bottom up approach, we first test the lower modules, which are module 4, module 5 and module 6. We can also combine the module 4 and 5 together to form a cluster and then test them. Then we move to the higher module, which is module 2 and module 3, which acts as a floors of a skyscraper building. And at the last, we will test our module 1, which is the rooftop. The next point is system testing. It is a type of software testing that is performed on a complete integrated system to evaluate it. It is mainly done after the integrated testing. The software testing is a type of testing where the entire system or the application is tested as a whole. This includes all the features, the components and the modules working together in a real life environment, just like the users will experience them. In the other words, you can say that the system testing is like making sure that when all the pieces of an application are put together, they work as a complete system, not just in isolation. For example, if you are building an YouTube application, you might have separate parts for video uploads, comments, search functionality, and video playback. System testing ensures that when all these parts come together, they work as expected without any issues. Basically, the system testing has 4 types. First is recovery testing. It checks the system ability to recover from failure. Second, the security testing. It prevents unauthorized internal and external to get access into the system. Third is performance testing. It evaluates the runtime performance of a software CPU load, throughput, response time and memory usage. Fourth, the stress testing. It determines the breakpoint of any system. The system testing basically tests the entire application, which the next point is validation testing. The validation testing checks if the final software meet all of the need of the user requirement. It ensures that the right product has been built and work as expected. It reduces bugs and failure after release. It helps to deliver high quality product. It also ensures software meets business needs and user expectation. Basically, validation testing is a type of testing that makes sure the software or the system meet the user need and requirement. Imagine if you are developing an application or a website. The developer work hard to create the features, but what if the feature they build don't actually meet the user needs? Maybe they built a video player that look great, but the user can't find the videos they want. That's where validation testing comes in. It ensures that what was built actually aligns with the user expectation and requirement. It's like making sure the features in a YouTube application actually make it easier for users to watch videos, to subscribe channels and to leave comment, just like they expected. So now with our 5th point, which is verification testing. Verification testing checks whether the software is being built correctly according to the requirement and design specification. It also ensures that the development process follows proper standard and guidelines. It catches the early errors in the development phases. It ensures software meets technical requirement, helps to reduce cost in later stage. The verification testing is done in each phase of development to ensure the code is working properly. For example, if you are building a simple login page for a website, when a user has entered their email address and password to access their account, the system compares the entered email password with the data stored in the backend database. The test will check if the system correctly checks that the entered email matches with the registered email in the database. If the email and password match, the system allows the user to log into the system. If the email or password doesn't match, the system shows an error message and verification test fails. meaning there's an issue with how the system is verifying the login credential. How it's done? Requirement verification. Basically, it first ensure that the gathered requirements are complete, consistent, feasible, and testable. It basically involves the stakeholder to validate the document requirement, match the user needs and the business goals. Second, design analysis. It reviews the software architecture and design documents to ensure they meet requirement. It checks the scalability, maintainability, performance, and security consideration. Means no external or unauthorized user entered into the system. The third point, which is code review. It is a systematic examination of source code to find bugs, to ensure coding standards, and improve the code quality. Often involves peer review, static analysis tools, and pull request reviews. Fourth, the unit testing, which means testing individual units or modules or components of the software, typically automated and performed by developer to ensure each part and function are expected in isolation. The fifth point, which is integration testing, verifies that the different modules, components, or the services of an application work together as intended. It ensures the data flow and the communication between a different component is correct after integration. For example, an online shopping website. The next point is unit testing in a term of object-oriented context. This is a previous year question which is asked for 6 marks. First, we have to write the definition of unit testing. The unit testing is a type of software testing where individual components or units of a program are tested. It is done to ensure each unit of the software performs as expected and meets its design specification. The unit testing means to checking one small part of your code, usually a single method or function, to make sure it works correctly on its own. The unit testing ensures that each class and methods are working correctly. It helps to detect the bugs in earlier stage in terms to improve the system. Its main feature is to support the reusability and the maintainability of the system. It simplifies developing by isolating small code unit. Key concepts. Testing classes and method, where classes is a blueprint or template for an object and method is a function which is defined inside a class that describes the behavior of an object. Second, the encapsulation. It means wrapping of the data. Private methods are usually tested indirectly. Inheritance. The test should ensure that the subclass behaves correctly. Fourth, polymorphism. Test should verify that different objects type produce correct behavior. The next point is integration testing in terms of object-oriented system. First, the integration testing is a level of software testing where individual units or components are combined and tested as a group to verify that they interact correctly, share data properly, and function as expected together. In object-oriented system, this means checking how classes, objects, and modules works in collaboration, not just alone. Basically, you are checking, do they pass the right data? Do they call the right method? Do they maintain data consistency? Or do they behave properly when they are combined? It ensures that the multiple objects and modules communicate properly. It detects the issues in encapsulation, polymorphism, and inheritance. It helps the data flow between object and external system. It identifies the bugs that are missed in unit testing. The key challenges in object-oriented integration testings are the encapsulation, which means wrapping of data. Object may hide internal details. Dependence management. Object rely on other classes. Polymorphism and inheritance. Method may behave differently in subclasses. It has 4 types. The first type is top-down approach. In the top-down approach, we start testing the top level modules or the higher level modules. And then at last we test the lower level modules. For example, we have taken the skyscraper building in which we test the rooftop first, then middle floors, and at the last the parking lot or the garden or the swimming pool, etc. Second, it is the bottom up approach. In this approach, we first test the lowest level modules, which are the foundation or base of the skyscraper building, then the middle levels, at the last the rooftop. Third is the big bang approach. It tests all the integrated at once. No, it is not recommended for the larger system. In this, you throw all the module together at once like a full-on explosion and test the whole system in one go without testing individual pieces first. Incremental approach. It is a way of building software step by step where each part of a software is developed and tested separately. It tests stepwise, starting with core component. It means you add and test one part of your code at a time instead of putting everything together all at once. For example, you are building a system step by step and test each step before moving to the next step. So the next point is black box testing. The black box testing is a type of testing in which it only focuses on the outer structure of the implementation that need to be tested. In other words, we can say that the tester does not require any internal function of the code. Black box testing will be done on external structure of the system. The input will go in black box testing and it produces an output as the response it will be tested. First it will take the input, then the black box will perform operation and it will give the output. We only need the output, we don't think of internal code. In other terms, we can also say that it is a type of software testing where the tester does not need to know the internal working of a system or an application. Instead of focusing the testing functionality of a software based on its input and output, the tester is concerned with whether the system behaves as expected rather than how it is achieved the result. For example, imagine you are testing a simple calculator application that performs addition, subtraction, multiplication and division. You are going to test it without knowing what's happening at internal code. Just by checking it if it gives the correct result based on the input you provide. For example, you give the basic addition 2 plus 2. It gives you 4, which means our internal code is correct and we get the output as 4. The next point is white box testing. It is basically the opposite of black box testing, where the white box testing techniques analyze the internal structure, the used data structure, internal design, code structure and working of the software rather than the functionality as in black box testing. It is also called as glass box, clear box or structural testing. It is also known as transparent box or opening box testing. In white box testing, the unit testing, integration testing and system testings combinedly gives us the white box testing. First we give the test case input, then we test the application code, which includes these all three testing systems, and then at the last we get the test case output. It basically tests the logic of the code. For example, imagine you have a simple calculator that performs addition, subtraction, multiplication and division. For an instance, if you are testing the addition function, you know that the calculator adds two numbers by following a specific set of rules. You would check that the calculator correctly add different types of number, positive number, negative number and 0 by verifying that the addition logic handle all these cases accurately. Let's say that the calculator app is supposed to add 3 and 5 to get 8. The white box testing, you just not verify the calculator shows 8 when you press those numbers, but also ensure that the internal logic is correctly implemented to produce this result. Essentially, white box testing focus on how the software works internally, checking that the internal process like condition, loops and calculation are functioning as expected. It involves testing the logic, flow and structure of the software from the inside. So now for the next point, which is the difference between the black box testing and white box testing. It was asked for 6 marks. First, in the black box testing, the test the software externally, focusing on input and output operation only. And in white box, it takes the internal code and logic. In black box, it checks the functionality without knowing the internal code, and in white box, it examines the code logic and its structure. The tester does not need the coding knowledge in black box testing, but the developer or tester needs the coding knowledge in white box testing. It provides input and check for the output. It looks inside the code, test condition and loops and paths in white box testing. It ensures software works correctly for the user in black box. It ensures the code works bug free in white box testing. In black box testing, implementation of code is not needed, and in white box testing, code implementation is necessary. Black box testing is mostly done by software testers. White box testing is mostly done by software developers. It is applicable to the higher level of testing software. It is generally applicable to the lower level of software testing. It least time consuming. It is most time consuming. For example, functional testing, user interface testing, and in white box testing, unit testing and path testing. The next point is strategy approach to testing, in which the first point is test planning. In this, you will plan how the testing will be done. You figure out what needs to be tested, who will be doing testing, and how long it will take. It includes understanding the requirement of project, what the software is supposed to do, decide which part of software will be tested and which won't. Plan the resources needed, people, tools, environment, resources, etc. It identifies risks, possible problems that might come up during testing. For conclusion, we have a clear plan for testing. Everything should work effectively. Second, test case design. In this step, where you create the specific test that will check if the software works properly or not. It includes write test case based on the requirement. These are instructions that tell you how to test the software. Make sure to test different situations like normal use and edges case. Example, what will happen if you enter too many characters? It helps to prioritize test based on what most important or risky. Creates detailed test that covers all the important part of the software. Test execution. In this, you actually run the test you created and see if a software works as expected. It includes set up the testing environment, the place where you run the test. Run the test and note down which test pass and which fails. Report any issues or bugs you find so the development team can fix them. Make sure the software works as it should and find any issues early. Data collection. Collect information from the test to understand how well the software is performing and identifying any problem. It includes track how many tests passed or failed. Looks at the trends in defects, bugs found, such as if there are repeated issues. Measure how software performs, speed, resources usage, etc. Conclusion. Gather useful data to understand how well the software is doing and if there are areas to improve. Effective evaluation. After testing, you review how well the testing process went and how effective it was. It includes assess whether the test covered all important areas of software. Review the bug found and how early they were discovered. Identify what worked well and what could be improving in future testing. Share results with team and stakeholder to improve testing the process for next time. Conclusion. Learn from the testing process and make improvement for the future. To understand better, we will take an example. Of simple calculator which performs the basic operation like addition, subtraction, multiplication, division. To ensure application works smoothly, we follow these all approaches. First, we follow the test plan. In this phase, we define what to test. For the calculator, we focus on ensuring addition, subtraction, multiplication and division features works correctly or not. We also allocate resources and set a timeline. We identify risk such as dividing by 0, and prioritize tests based on this risk. Second, the test case design. We create text scenario like check if 3 plus 5 which is equal to 8 or check if 10 divided by 2 equals to 5. We define inputs and expected outputs. We consider edge cases like testing for division by 0 or very large numbers. And third, test execution. During the execution, we run these test cases. For example, we input 3 plus 5 and check if the result is 8. If the application gives the wrong result or crashes, we log the bug or fix it and retest the features. Data collection. In data collection, we gather data on test performance. For example, we measure how long it takes to perform complex calculation, or if the app crashes with certain inputs. We also check which device or platform the application works based on: mobile, desktop, laptop, etc. Effective evaluation. Finally, we analyze the test result. If the application consistency fails at performing division by 0, we prioritize fixing them. We use the result to improve the application and testing process, ensuring future versions are better. The next point is alpha testing and beta testing. First, we will try to understand its beta definition and with the help of example. Then we will move forward to the previous year question of difference between alpha testing. Alpha testing is a first phase of testing where the development team tests the software in-house. It is performed to fix bugs before releasing the software to a selected group of users. The goal is to identify issues and ensure the software functions as expected. For example, a software company tests its application internally by the developer and quality assurance team before it is shown to the outside users. Second, beta testing. Beta testing is the second phase where the software is released to a select group of external users outside the company. The goal is to identify any remaining bugs, gather user feedback, and see how the software performs in real world conditions. For example, a company releases a beta version of their application to a group of users to test its various environments, get feedback, and fix any last minute issues before the official release. And now the difference between alpha testing and beta testing. First, the alpha testing. First phase of user acceptance testing, which is done internally. It is the second phase of testing, which is done externally with the help of user. The alpha testing is performed by internal team, example developer and Q&A. The beta testing is done by the real user, customer or external tester. Alpha testing is done in simulated or in lab environment, and beta testing is done in real world environment. They are used to identify major bugs, functionalities, issues and usability problems. It is used to evaluate software performance, usability and user experience in real world condition. Alpha testing. Bugs are found and fixed before the beta testing, and bugs are found and fixed before the final release in beta testing. It has longer testing phase and beta testing has a shorter testing phase. It has limited user involvement, and in beta testing it has higher user involvement. Alpha testing has higher chance of encountering critical bugs, and beta testing has low risk because of they are already found in the alpha testing. The bugs are already found in alpha testing. In alpha testing is always conducted before the beta testing, and the beta testing is always conducted before the alpha testing.